Okay, hi, welcome to today's talk on Power of Unreal Engine. I'm Kavan Raj. I'm the lead programmer for BotRods. I have 9+ years of experience and have a master's in computer games technology. So, welcome to the talk. Before getting into the session, I would like to give you a brief introduction about who are we. Holy Corporation is a Bangalore studio, started back in 2014. We ship 20+ titles both in-house as well as service projects, and we won numerous awards. BotRods is one of the project from Holy Corporation, and that is what I'll be speaking about today. So BotRods is an arcade racing game. It's created using Unreal Engine. It resembles Mario Kart, CTR, and other kart racing games in terms of the setup, but in terms of functionality, it is unique. It is one of its kind. To create this unique content, we wanted an engine which is equally powerful. That is the reason why we chose Unreal Engine, because Unreal Engine is not just powerful, it is also extremely flexible. The flexibility of the Unreal Engine comes from its ability to modify its source code. You can tweak it, you can modify it, you could add custom functionalities and a lot more to it. BotRods took the maximum advantage of Unreal Engine's flexibility. Let me quickly go ahead and explain why is it important for studios like us to create unique content. It is important because the product needs to stand out from the market. Unlike AAA studios, we do not have enough budget or an IP which is iterated over a period of time, like Mario Kart or CTR and all the big names. So it is only logical for us to create content that can speak for itself. And that was the entire ideology behind creating BotRods. Let's quickly take a look at the world of BotRods. It's an adorable, futuristic world in which are occupied by these cute little species who are really into their robot vehicles. Same like human beings, how we are into bikes and cars, they are into their robot vehicles. These robot vehicles are called as bots, and these species are called as characters. Unlike our world, they have these bots have characteristics. Like each bot have emotions. They're different from each other. They are agile. The comparison here can be like how Transformers are the same, but Bumblebee is different from Optimus Prime. So it's a very similar analogy here. Yeah. And they settle every dispute through racing, and that is the main theme behind BotRods racing. Unique features comes with unique challenges. So what are the unique features of BotRods? It is the bot itself and the way they race. The bots are very acrobatic. What I mean by acrobatic is like they could jump, flip, they could ram into each other. It feels more like 100-meter hurdles at Olympics, mixed along with the kart racing, where they could just drift boost, pick up power-ups, shoot at each other, at the same time having this nice cashback mechanics. That's pretty much can race on any terrain, so they're not just limited to the racetrack like other games. They could also use the sidewalks, they could also use the obstacles, where they can jump on the obstacle and flip to ram an opponent or to get the power-up or the speed boost. And they could also redefine gravity. What I mean by redefining gravity is like there are certain levels where you are forced to do a 360-degree rotation in order to take the shortcut, which can reduce your track time into half. Overall, the character, the bot, is the combination of both karting as well as quadruped humanoid-like character, so which has this unique feeling towards the game. So one of the major challenges faced was to contain all these things together into a nice arcade-ish game, which has to be fluid at the same time very responsive. This was achieved by solving an array of complex problems over a period of time. It was an iterative process, but finally we got this nice output where everything was put together. So let's take a look at BotRods at its current state. let's get into the development process of Botrots. The first step for us was to create the prototype. So we want to quickly iterate to test the look and the feel of the game. So we used the Unreal Engine's existing templates. We used Field Vehicle to see how the bots feel in the world. So once we are satisfied with our prototype, we then moved on setting the goals for our game development. So some of our initial goals were like how much frame rates the game has to run, how many split screens do we want to have, what are the major platforms we're going to ship the title for, and we were also extremely rigid on how fluid our gameplay has to be. So then we quickly realized that in order to get everything done in the way we wanted, we want to create a system that is best fit for the game. So we decided to create everything from ground up. I'd like to mention some of Unreal Engine's flexibility in creating Botrots. So the ability to have native C++ code without creating objects. So what does it mean is that like you don't need to have any physical object or component at the scene, but you could still have the native C++ code, which is very lightweight. And the entire Botrot system is created around this ability to modify engine code. Since you have access to your source code, if you want to change something in the source code very specific to the project, you can do that, but it's just the compilation time. Like if you change something, then you need to wait for the compilation. It might take a little bit of while based on your system. Custom codes work seamlessly with blueprints. So I could access those native codes. Like I create the instance inside one of my component, and using those components blueprint functions, I can access those native codes, and it works seamlessly with blueprint, which was very handy in IGDC system, which is created in Botrots, which is used in Botrots. The ability to create custom blueprint function libraries that can be used by artists and other non-programmers. This is pretty straightforward. It is like you create a function with the C++, like the programmers do all the heavy lifting and can give the opening to your artist or someone who works in other areas like UI or materials and other part of things. They could just get these functions and can implement the functionalities they want. So ability to create a layer between existing system, I will just explain that in a few minutes. So let's take a brief look at the custom system in Botrots. Basically it has a physics layer which nullifies the existing physics system and adds the functionality that helps bot to interact with the world. So we'll be taking a detailed look on the later slides. So I'll be moving on to navigation system. Navigation system is a very simple system, spline and node based system, which helps to guide the AI and the ability system and any abilities that requires navigation. So AI is pretty much straightforward. Since we are not using Unreal's AI, we created our own lightweighted system. Game control framework, and this is the game loop. It's a custom game loop which we use, which nicely switch between the campaign modes and other different modes in the game. Spawn system, since we have a custom character, we need to initialize a lot of variables during its creation. During its instance creation, so the spawn system comes in handy and it initializes all those variables. The ability system is again a state machine based system where the bot can be in a single behavior at a time. So this system fits perfectly for our game. UI control system in Botrots, we need to have an ability to use multiple controllers in the main menu, and it was not available with Unreal's control system. So we did a workaround. We created a layer which enables us to use multiple controllers at the same time, even without initializing players. So yeah, that's another custom system. Testing tools, like the testing tools are basically what happens is like you could simulate all parts of the games even without being in the game loop. It is super handy because you don't waste time in terms of testing. 90% of the system is written using C++, except for the UI, which uses blueprints pretty heavily. The same concerns of bots was one of the major challenges during the development of bot rods because of the complex nature of the problem. Bot rods is a physics-driven game. The constraints were the bot have to be agile, able to navigate on any terrain, and should be able to have all the behaviors as caught, including acrobatic skills, drift boost, speed boost, and other ability interactions, makes the design of the system complex than usual. We know there is no out-of-box solution for these type of problems, so we understood that the desired effect can be only achieved by heavily modifying the existing system. So we approached this problem by creating a custom solution that is unique for bot rods. That is implementation of the physics layer, which acts as an intermediate between the physics component and the pawn, which drives all the physics aspect of the game, and this turned out to be a perfect solution when it was iterated over a period of time. Initially, for the prototype, we took a box primitive component and added a force at multiple points to get a suspension effect. Only after a few attempts it was stabilized. It was a disaster initially. Adding movement to this was another problem because of center of mass. This was rectified by changing the mass based on the movement. This was far from perfection. Only after again recreating these things caught a decent result. Even the ground collision, that was another issue where when the bot doesn't have a physical collider, it doesn't have that stable effect when it jumps toward the ground. So we rectified it by adding a collider that only acts at a certain ratio of gravity. So collision with other bot was a problem too, because the outcome of the collision was usually random. So by doing these prototypes and taking all these principles together, we converted this into a separate layer, which was the physics layer, which drives the entire game system of bot rods at the moment. And it turns out to be a perfect solution. Let's take a look at some of the clips which are recorded during the early prototypes of bot rods. Okay, physics layer. Finally we are here. So what is the physics layer? Physics layer is a linear system that is made for bot rods. How does it work? It starts by nullifying all the existing calculation on the physics component. Then it calculates the movement and collision for the bot. It also contains custom functionalities like add, force, impulse, overtime, force overtime. These overtime functionalities are used, this is calculated using time and delegates. Any functionality that uses time and delegates will be verified before applying to the final value. And it also calculates other physics-related interactions that is based on characteristics, bot's characteristics like strength, agility, and other properties. Because these properties affect collision and other behavior. For example, if the bot is much stronger, the ability for the bot to recover is much higher. So the calculation is done here in the physics layer. It also applies map-related physics calculations, like for example, certain map have area where you have high resistance, and that will be calculated here. It emulates resistance. What it means is that since we are not using most of the existing system, we emulate it here manually just by a mathematical model. And it also acts as a kill switch if there is a huge spike in frames. Since we are using variable frame rate, it is necessary for us to normalize in the event of spike. If we are using fixed frame rate, then it should be fine. Since we are not using it, it is very important. It acts as a normalizing tool by calculating average frame rate. So this is very important because like we want to make sure bot rods always works with the stable frame rate. So once everything is done, it applies the final calculation back to the physics component. So this is how the physics layer works.